An optometrist office falls under Patient Care Article 517.13a. This article applies to areas where patients are intended to be present for examination or treatment. This includes examination rooms, treatment rooms, operating rooms, recovery rooms, and patient waiting areas. Hospital-grade receptacles are not required for optometrist offices. Isolated ground is also not required for optometrist offices. However, optometrist offices may require redundant grounding if they have critical patient care equipment that must be continuously powered. Redundant grounding involves providing a backup ground path in case the primary ground path fails. This is achieved by connecting the electrical system to multiple grounding electrodes. For optometrist offices, redundant grounding may be required for the following critical patient care equipment: firstly, lasers used for eye surgery; secondly, electrocardiogram, abbreviated ECG machines; and thirdly, pulse oximeters. An optometrist office is considered a patient care area under Article 517.13a. While hospital-grade receptacles and isolated ground are not required, redundant grounding may be necessary for critical patient care equipment that must be continuously powered. The specific grounding requirements will depend on the type of equipment used and the risk of electrical hazards. Let's delve further into the requirements of Article 517.13 and how it applies to optometrist offices. The National Electrical Code, abbreviated NEC, is a comprehensive set of standards governing electrical installations for safety. Article 517 specifically addresses healthcare facilities. Article 517.13 focuses on the grounding and bonding requirements in patient care areas to minimize the risk of electrical shock. Grounding provides a low impedance path for fault current to return to the source, tripping a circuit breaker or fuse and de-energizing the circuit quickly. Bonding ensures that all metal parts in the patient care area are at the same electrical potential, further reducing the risk of shock. While the NEC does not mandate hospital-grade receptacles and isolated ground for optometrist offices, it is crucial to understand when redundant grounding becomes necessary. Redundant grounding ensures that if the primary grounding path fails, a secondary path is available to maintain a safe electrical environment. This is particularly important for equipment that directly impacts patient safety. Let's consider the equipment mentioned earlier. Lasers used for eye surgery are sophisticated devices that rely on precise electrical control. A failure in the grounding system could lead to erratic laser behavior or, in the worst-case scenario, an electrical shock to the patient. Electrocardiogram, abbreviated ECG, machines monitor the electrical activity of the heart. Accurate readings depend on a stable and reliable electrical environment. A faulty ground could introduce noise into the signal, leading to misdiagnosis or inappropriate treatment. Pulse oximeters measure the oxygen saturation in a patient's blood. These devices are often used during procedures or examinations to monitor the patient's vital signs. An unreliable ground could cause the oximeter to malfunction, providing inaccurate readings. To implement redundant grounding, an optometrist's office needs to ensure that the electrical system has multiple connections to the grounding electrode system. The grounding electrode system typically consists of items such as a ground rod, a metal water pipe, or a concrete encased electrode. The connections from the electrical panels and equipment to these electrodes must be robust and properly sized according to the NEC. Additionally, it is important to regularly inspect and test the grounding system to ensure its effectiveness. This includes visual inspections of grounding connections and electrical testing to verify the impedance of the grounding paths. Consulting with a qualified electrical engineer or electrician is highly recommended to determine the specific grounding requirements for an optometrist's office. These professionals can assess the equipment being used, evaluate the existing electrical system, and design a grounding system that meets the NEC requirements and minimizes the risk of electrical hazards. The NEC provides tables and guidelines for sizing grounding conductors based on the size of the overcurrent protection devices in the circuit. For example, NEC Table 250.122 provides minimum sizes for equipment grounding conductors. It is essential to follow these guidelines to ensure that the grounding conductors are capable of safely carrying fault currents. Furthermore, bonding jumpers are used to connect metal parts together to ensure electrical continuity. These jumpers must also be sized appropriately and installed correctly. NEC Section 250.96 provides requirements for bonding metal parts that are likely to become energized. In addition to the grounding and bonding requirements, it is important to consider the overall electrical safety practices in the optometrist's office. This includes regular inspections of electrical equipment, proper use of extension cords and surge protectors, and employee training on electrical safety procedures. Employees should be trained to recognize potential electrical hazards such as frayed cords, damaged receptacles, and overloaded circuits. They should also know how to respond to electrical emergencies, such as shocks or fires. Regular training and awareness programs can help prevent accidents and ensure a safe working environment. Moreover, it is important to keep electrical panels and equipment rooms clean and free of obstructions. This allows for easy access for maintenance and repairs. Ensure that electrical panels are properly labeled and that circuit directories are up to date. This helps to quickly identify and isolate circuits in case of an emergency. Consider the use of ground fault circuit interrupters, abbreviated GFCIs, in areas where there is a risk of water exposure, such as restrooms and break rooms. GFCIs are designed to quickly detect ground faults and interrupt the circuit, preventing electrical shocks. The NEC requires GFCIs in certain locations, and it is a good practice to install them in other areas where there is a potential hazard. Surge protection devices, abbreviated SPD, can help protect sensitive electronic equipment from voltage spikes caused by lightning or other electrical disturbances. These devices are typically installed at the electrical panel and can help prevent damage to computers, lasers, and other electronic equipment. When selecting SPD, it is important to choose devices that are appropriately rated for the voltage and current of the electrical system. Regular maintenance of the electrical system is essential to ensure its continued safety and reliability. This includes periodic inspections of wiring, connections, and equipment. Any damaged or worn component should be replaced promptly. Consider establishing a preventive maintenance program to identify and address potential problems before they lead to failures. Furthermore, it is important to keep accurate records of all electrical work performed in the optometrist office. This includes records of inspections, repairs, and modifications. These records can be helpful in troubleshooting problems and ensuring that the electrical system is properly maintained. When making any changes or additions to the electrical system, it is important to obtain the necessary permits and approvals from the local electrical authority. This ensures that the work is performed in accordance with the NEC and other applicable codes. Working with a licensed electrical contractor can help ensure that all electrical work is done safely and correctly. In summary, while hospital-grade receptacles and isolated ground are not generally required in an optometrist's office, understanding the requirement for redundant grounding under Article 517.13 of the NEC is critical. Proper grounding and bonding practices are essential to protect patients and staff from electrical hazards. Regular inspections, maintenance, and employee training can help ensure a safe electrical environment. Always consult with qualified electrical professionals to determine the specific grounding requirements for your optometrist's office and to ensure compliance with all applicable codes and standards. Remember that the safety of patients and staff should always be the top priority when it comes to electrical installations and maintenance. By following the guidelines and recommendations outlined in the NEC and consulting with qualified professionals, you can create a safe and reliable electrical environment in your optometrist's office. The NEC is a living document that is updated regularly to reflect changes in technology and industry best practices. It is important to stay informed about the latest revisions to the NEC and to ensure that your electrical system is compliant with the current edition. Consider subscribing to industry publications and attending training courses to stay up to date on the latest electrical safety standards. By investing in electrical safety, you can protect your patients, staff, and business from the risks associated with electrical hazards. A well-maintained and properly grounded electrical system is an essential part of a safe and successful optometrist's office. The grounding electrode system, as previously mentioned, is a critical component of the overall grounding system. The NEC provides specific requirements for the installation and connection of grounding electrodes. For example, ground rods must be at least 8 feet in length and must be driven into the ground to a depth of at least 8 feet. Metal water pipes used as grounding electrodes must have continuous electrical contact with the earth and must be supplemented by an additional grounding electrode, such as a ground rod. Concrete encased electrodes, also known as UFA grounds, must consist of at least 20 feet of bare copper conductor encased in concrete. The NEC specifies the minimum size of the grounding electrode conductor, which connects the grounding electrode to the electrical system. The size of the grounding electrode conductor is based on the size of the service entrance conductors. It is important to follow the NEC guidelines to ensure that the grounding electrode conductor is capable of safely carrying fault currents. In addition to the grounding electrode system, the NEC also requires the installation of a main bonding jumper, which connects the grounded conductor to the equipment grounding system at the service entrance. The main bonding jumper ensures that all metal parts in the electrical system are bonded together to create a low impedance path for fault current. The size of the main bonding jumper is also based on the size of the service entrance conductors. The NEC provides tables and guidelines for determining the appropriate size of the main bonding jumper. Proper installation and maintenance of the main bonding jumper are essential for ensuring the safety of the electrical system. In patient care areas, the NEC requires that all exposed conductive surfaces that are likely to become energized be bonded together to create an equipotential plane. This includes metal door frames, metal window frames, and metal plumbing pipes. The purpose of the equipotential plane is to minimize the voltage differences between these surfaces, reducing the risk of electrical shock. The NEC provides specific requirements for the bonding of these surfaces, including the size and type of bonding conductors. Regular inspection and testing of the equipotential plane are essential to ensure its effectiveness. In addition to the bonding requirements, the NEC also specifies the requirements for the use of isolated power systems in certain patient care areas. Isolated power systems are designed to provide a higher level of electrical safety in areas where patients are at high risk of electrical shock, such as operating rooms. Isolated power systems use a special transformer to isolate the electrical system from ground, reducing the risk of ground faults. The NEC provides specific requirements for the installation and maintenance of isolated power systems. However, as we established, these are typically not needed in optometrist offices. It is important to note that the NEC is not the only standard that applies to electrical safety in healthcare facilities. Other standards, such as those published by the National Fire Protection Association, abbreviated NFPA, and the Joint Commission, may also be applicable. It is important to be aware of all applicable standards and to ensure that your electrical system is compliant with all requirements. Working with a qualified electrical engineer or electrician who is familiar with healthcare electrical standards can help ensure compliance and minimize the risk of electrical hazards. In conclusion, understanding and complying with the electrical safety requirements in patient care areas is essential for protecting patients and staff from electrical hazards. While hospital-grade receptacles and isolated ground are not generally required in an optometrist's office, understanding the need for redundant grounding and the proper installation and maintenance of grounding and bonding systems are critical. Regular inspections, maintenance, and employee training can help ensure a safe electrical environment. Always consult with qualified electrical professionals to determine the specific requirements for your facility and to ensure compliance with all applicable codes and standards. Remember that electrical safety is an ongoing process that requires constant vigilance and attention to detail. By investing in electrical safety, you can protect your patients, staff, and business from the risks associated with electrical hazards. A well-maintained and properly grounded electrical system is an essential part of a safe and successful healthcare facility.